So now we're going to take what we know about solving equations and we're going to solve literal equations. Well, the first question has got to be, what on earth is a literal equation? A literal equation is mostly variables. There will be some numbers involved, but there will be more than one variable. So you're going, oh great, I put one letter in an equation and now there's going to be more than one? Yeah, there is. These are often formulas. You are familiar with formulas. You've used them to find area, to find volume. For example, when you did the area of a circle, area equals pi r squared. That's two variables, right? The area and the radius. We know pi. Pi is not a variable. So this is a formula, but it's also a literal equation. So how do we solve a literal equation? Well, just like you solve regular equations, you use inverse operations. Okay, but the inverse operations, I'm sorry, I just lost my train of thought. It's just going to look a little weird. You're still going to be using inverse operations. If something is added, you're going to subtract. If it's multiplied, you're going to divide. It's just going to look strange. So we're going to use what we know about regular equations to these literal equations, and hopefully the more practice you get, the more sense it will make. Okay, so let's look at one we know how to solve without any problems. 3 equals x minus 2. So if I'm solving for x here, I look for my variable. I'm trying to isolate it. I'm subtracting 2. So I'm going to add 2 to both sides of the equal sign. And I get x equals 5, right? No problem. Now, let's look at this equation. That's all variables. M equals c minus s. Now, when there's more than one variable, they've got to tell you what to solve for. So let's say here we're going to solve for c. So we look and we find c. Here's c. What's keeping c from being isolated? This minus s. So I've got to use the inverse operation of minus s. The inverse operation, I'm going to add s, right? And whatever I do to one side of the equal sign, I have to do to the other. So then I look over here, well, m plus s, those are not like terms. I cannot combine them. So the only thing I can do is write m plus s equals c. The s minus s, those were inverse operations, so that became 0. And then my answer is c equals m plus s. So it looks a little weird. I just couldn't combine those things, so I copied them as is. All right, let's look at some more that are more like one step. Here is a one step. 12 equals 3y. That's multiplication. We know, no problem, we would divide both sides by 3, and we would get y equals 4. Well, what if it's a literal equation? Here I've got d equals rt. This is a distance formula that you're going to come across every once in a while. Distance equals rate times time. And I want to solve for t. Well, here's t. What's keeping it from being isolated? R is. What's the operation between r and t? Multiplication. So to solve, I'm going to divide both sides by r. These r's will cancel, and I end up with t equals d over r, or d divided by r. I just rearranged this formula to where t was isolated instead of d. Here's one you're familiar with, the volume formula. Volume equals length times width times height. I want to solve for h. So I look, L and W are in the way. They are keeping h from being isolated. This whole thing is multiplied, right? So what's kind of cool here is I can divide by L and W at the same time. I'm going to divide both sides by L and W. This side's going to cancel, and I'm left with h equals V over L times W. Now, what about a division problem? We can do this one. M divided by 3 equals 7. The operation here is division, so I'm going to multiply both sides by 3. These 3's would cancel, and I get m equals 21. Same thing over here. I've got D equals M over V. This is actually a formula you're going to use in science this year. They tell us to solve for M. I'm going to, this is division, right? M divided by V. So to get rid of this V, I'm going to multiply both sides by V. These V's cancel, and I get M equals D times V. You could also write it the other way. Doesn't really matter because multiplication is commutative. So what if I got fractions going on? Well, let's look at an equation we know how to solve. 1/4 Z equals 7. Well, this is 1/4 times Z, so how we were showing this is not like that, we would divide both sides by 1/4. The 1/4 divided by 1/4 is 1, and we'd get Z equals, and remember we would say that 7 divided by 1/4 is the same as 7 times 4 over 1. You multiply by the reciprocal, so we got Z equals 28. Okay, same idea when I've got a fraction in a formula. This is a formula you're familiar with. This is your area of a triangle formula. Area equals 1/2 base times height. Now, we got this 1/2 going on, we got this B going on, and we got to solve for H. We're going to take care of the fraction first. We're going to divide both sides by 1/2, okay? Those are going to cancel. We're left with BH over on the right side. Now, A divided by 1/2 is the same thing as A times 2 over 1, right? So this is really 2A. So I went to the side just like I would with the numbers. I went to the side with the variable and the fraction. It's the same thing, works out the same way. Now, I still don't have H isolated. I've got B times H, so my inverse operation, I'm going to divide both sides by B. Now these cancel, and I get H equals 2A over B. Okay? Looks a little weird. You're just rearranging using inverse operations. Now, this is one we looked at last week that we had a little bit of trouble with. We have x plus 3 all over 5. Remember, that's a division symbol. It's also a grouping symbol. Remember, it puts this x plus 3 in parentheses. Since this is divided by 5, I have to multiply both sides by 5. These cancel. I end up with x plus 3 equals 20. Now it's a one-step equation, and my final answer is x equals 17. Okay? What does that look like if I have all variables? Look at this one. A equals B plus C all over D. So don't forget, this B plus C right now is in parentheses because this fraction bar is a grouping symbol. It's divided by D, so I'm going to multiply both sides by D. Okay, these D's cancel. I end up with B plus C equals AD or DA. Either one would work, right? I'm solving for B. Right now it's B plus C, so I've got to do the inverse operation of plus C. I've got to subtract C from both sides. C minus C is 0. I'm left with B. Now, AD minus C. None of that is like terms, so I just copy it. AD minus C. So, looks weird, but it's just using your inverse operations. All right, what about problems that look like two-step equations? Okay, we can do these right here in our sleep. 2x minus 5 equals 13. I'm trying to isolate the x. I've got to take care of this minus 5 first, so the first thing I do is add 5 to both sides. I get 2x equals 18. Then I'm going to divide both sides by 2, and I get x equals 9, right? So first I took care of the part that wasn't with the variable, then I took care of the coefficient of the variable. I got my answer. These are going to be the same way. So let's look at this one. Ax minus b equals c, and we're solving for x. So I find x. I've got to save it to the very end. I've got to get rid of this minus b. So I'm going to use my inverse operation. I'm going to add b to both sides. So I get ax equals, and I can't combine c and b. They're not like terms, so I just have to write c plus b. Then I look here, I remember that I'm solving for x. This is a times x, so the inverse operation is divide by x. Now look over here, I've got to divide the whole side by a, not by x. I said x a second ago, a. And you divide the whole side, so it looks, again, like I've said about a bazillion times, a little funky. So x equals c plus b over a. This is actually sort of the opposite of the one we just did a minute ago. Okay? All right, let's do another one. If you want to stop and try it on your own, please do. If you want to listen and see a couple more as I work them, you can do that too. All right, ax plus by equals c. This is actually something we're going to use a lot this year. We're going to see it later. And we need to solve it for y. We're going to do that a lot this year too. So I find my term with y. I'm going to save it to the very end. I've got to get rid of this ax. It's a positive ax, so my inverse operation, I'm going to subtract ax from both sides. Ax minus ax is 0. I bring down the by. I cannot combine c and ax, so I just write c minus a times x. Okay? Then this is b times y. So since I'm trying to solve for b, I'm going to divide both sides. I'm sorry, I said it again. Since I'm trying to solve for y, and it's b times y, I'm going to divide both sides by b. Got to divide the whole other side by b, and I end up with y equals c minus ax all over b. All right, one more. This would be a good one to try on your own because it's almost exactly like the first one. This one says a equals p plus PRT. Looks like some sort of interest formula, doesn't it? Okay, so we're going to solve for t. So I need to leave this whole thing that t is a part of alone, and I got to get rid of the p first. So that's a positive p, so I'm going to subtract p from both sides. That gives me a minus p, because I can't combine those. Don't lose your equal sign. P minus p is 0, and I bring down PRT. Okay, so here's t. P and R are multiplied by t, so my inverse operation would be to divide both sides by PR. Remember when we've got this two terms going over here, we divide the whole thing by PR. So these PRs cancel and become 1, and I have t equals a minus p all over PR. Every one of these is different. Every one of these is a little weird. You just have to keep practicing, keep looking for your inverse operations, and as you need help, don't hesitate to ask.